Yeah. So good morning, all of you.
Good morning, sir.
Yeah. Today we are discussing another type of welding method, electric arc welding. So generally, last class we discussed about resistance welding. Today's class we are discussing electric arc welding. Generally, what is electric arc welding? So arc welding is the process of joining two metal. Generally, welding is the joining of two metallic pieces. So electric arc welding is the process of joining two metallic pieces or melting of metal is obtained due to heat developed by an arc struck between electrode and metal. Here heat, how to develop heat here in this case, arc struck between electrode and metal to be welded or between the two electrodes. This is the figure of arrangement of electric welding equipment. This is a base metal, this is welding rod, so deposited metal, this is deposited metal, so electrode holder. This is the part of electrode holder. This is a galvanometer. Then how much of current flows through the here while heating the metal or electrode. So generally, what is the process involved here is in this process, electric arc produces bringing of two conductors. One is electrode is a conductor and metal piece is a conductor. So electrode is a conductor, two conductors connected a suitable source of electric current. I am giving supply by using transformer or whatever. I am giving supply suitable source of electric current. In contact and then separated by small gaps. So I am separating, one is metal, one is electrode. In between, I am giving small gap. So then giving to the supply to the means the automatically arc, then whatever means arc blows due to the ionization, give intense to heat. It produces the heat. That heat automatically due to that heat to melt or to join the two metal pieces, metal and electrode, then two metals, dissimilar metals or what? Dissimilar metals or same metals. So here we are using filler metal, we are using here to weld the two metal pieces. There is a process involved here, arrangement of electric welding equipment. So here, generally, we also call electric arc non-pressure welding. See, non-pressure welding. Then what are the factors depend upon the following? Length of arc required for welding depending upon the following factors. One is surface coating and the type of electrodes are used, surface coating and the type of electrodes are used, and the position of welding. Which position of welding is also one of the factor. Length of arc required. Then amount of current used. Basically, rating is very, very important in electric arc welding. So other than high rating or low rating, some low rating case, it takes more time than most of the metal of filler material is wasted, and high current, then automatically breakage or some failures occur in the whatever in equipment device. Such cases, amount of current, how much of current, based on that you have to set the rating of materials, rating of metals. So that is that's why most important factor is amount of current used. And one more thing is when the supply given across the conductor separated by distance apart, air gap present between two conductors gets signed as arc welding in the process. Generally here, like induction process, same thing here also involved too. One is metal and electrode, in between is a small gap is there. When if you are given to the supply to the metal or whatever electrode, two conductors, two conductors, metal and electrode are two conductors. So automatically it to be ionized and arc welding in the progress. Then ionization means arc path surrounding areas increases. Then after sprinkling the whatever the ionization process, then arc whatever sprinkling this, then automatically heat the throughout the means automatically the metal is strength will be reduced, then automatically to melt or to connect the two metals. That is the one of process here. Also generally negative resistance characteristics. Arc is in a negative resistance characteristics, not in a positive resistance characteristics. So here whatever the material metal conductor the negative resistance characteristics. Then temperature arc should be 3500 degrees. Up to that the metals we are using their temperature, and usually the AC supply is 70 to 100 volts and 50 to 60 volts of DC supply is sufficient to struck the arc in the air gap. This is the ranges, and some case to 20 to 30 is only required to maintain it. So certain maintenance case is required 20 to 30 volts. So the ranges of voltages and voltage AC supply and DC supply and temperature, and based on the different types of using the material of arc case, then different types of electric arc welding. One is carbon arc welding, metal arc welding, atomic hydrogen arc welding, and inert gas metal arc welding, and submerged arc welding. These are the different types of welding types, arc welding types: carbon arc, metal arc, atomic hydrogen arc, inert gas metal arc, and submerged arc welding. And one more thing is, first one is carbon arc welding. So carbon arc welding, here two carbon electrodes, one is the carbon electrode and the base metal. Or one is the two carbon electrodes stuck between two carbon electrode and base metal. This is the diagram of a carbon electrode. One is electrode holder, another electrode, and then base metal. Base metal, in place of base metal, if you are using carbon electrode, one more. So in between, arc is there here. Arc. So we are given to this supply here, electrode holder, like switch. This is a clamp material to fit the, it's not moving purpose, not moving if you are using clamp, just like clamp. So what is the process involved here means, then if you are given to this supply via electrode holder to heat the electrode and base metal, then I have to produce the arc, and based on that to melt or to join the two metals. So here most of the cases we prefer DC supply for carbon arc welding. So then yes, in case of AC, the carbon arc welding, carbon graphite rods are used as electrode. Generally in carbon arc welding case, the carbon or graphite can use. Graphite also some few percentage of, most of the percentage in carbon material. Thus we all know that as a chemically, then most of graphite material also some few content is carbon. That's why in place of electrode, which type of material we are using, metal you are using carbon electrode or graphite rod, carbon rod or graphite rod. Why means longer life and low resistance. Graphite, that's why capable of conducting. That is also graphite material is conducting more current. That's why you are using here. And the electrode is 3200 degrees temperature, and positive electrode is 3900 degrees temperature. Generally, how much of diameter of electrode? 2.5 centimeter diameter, and current of 500 to 800 ampere employed to deposit large amount of filler material on the base metal. And one more thing is, what are the advantages if you are using carbon arc welding case? Heat developed during welding can be easily controlled by adjusting length of the arc. So generally we all know that in synonymously, then we all know that R equal to rho L by A. So what is the formula for R? Resistance equal to rho L by A. So when length of the arc changes, resistance value changes. Based on that, you are adjusting the length of that. Is the one of most advantageous if you are using carbon arc welding, easily controlled by adjusting the length of the arc. When length changes, resistance value changes. Resistance value changes means then automatically heat developing the whatever the way during the welding, easily way to control. That's the one of advantage of this carbon arc welding. And one more thing is, it is quite clean, simple, and less expensive when compared to other welding processes, and easily adaptable for automation. And you can use ferrous and non-ferrous metal can be welded by using this carbon arc welding case. And one more, so another thing is disadvantages. Input current required in the welding for working piece to rise temperature, melting or welding. Temperature is approximately double the metal arc welding. If you go for compare with metal arc welding, so rise in temperature is compared with the metal arc welding double value. That is the one of drawback here. When high temperature means certain case, then we are not in control or whatever other control the environment. That is one of problem here. And in case of ferrous metal, there is a chance to disintegrating the carbon at high temperature. Then we double the temperature means high temperature case disintegrating. Disintegrating means then harder and deposit brittlement, then metal will change the position characteristics. Then somewhat difficult filler for this case, filler material is required. Such filler material is more filler material is required for this case. That is one of drawback of this carbon arc welding case. Then applications, stainless steel with thinner gauges for stainless steel, thinner gauges purpose. We can use this carbon arc welding. Useful for welding thin high-grade nickel alloys and galvanized sheets using copper, silicon, manganese alloy filler material metal. And metal arc electrodes are used same metal and working piece to be welded. And different applications are there where these are the one of thing here. Metal arc welding. Metal arc second case is metal arc welding. Metal arc welding is like this here: base metal, and electrode holder, and deposit metal, and flux coated metal arc. The arc will be produced when if you are given to supply A supply here positive temperature, positive electrode, then negative metal electrode is 2400 and 2600 is the positive base metal. So this is a positive base metal. Positive case 2600, 2400 degrees temperature. Can use both AC and DC for 50 to 60, AC for 80 to 90 volts. And the voltage drop across arc less than 13 volts is maintained. The less than, and the drop value is less than 13 volts only. Have to maintain. So more than that, you have to take precaution. And temperature also 10 to 500 ampere depending upon type of work to be welded. And disadvantages of metal arc welding is the presence of arc blow, distortion of arc stream from the intended path due to magnetic forces of non-uniform magnetic field. With ACR blow considerably reduced compared with AC. That is one of drawbacks for giving the DC metal arc welding case. So then one more important thing is another type is atomic hydrogen arc welding. If you are seeing this atomic arc hydrogen welding here, two tungsten electrodes is supply we are connecting here, two tungsten electrodes. So in between in tungsten like a light filament bulb, like bulb inside the what is the hydrogen gas, that's why name called hydrogen atomic. So another thing is base metal. This is base metal, pool molten metal, base metal. When if you are giving a supply here, then tungsten electrodes are heated and it produces the heat, or it means arc will produce and automatically to melt or to join or dissimilar to join the two metals. Process here, same process here. Then about 400 degrees of subset, then hydrogen gas means then up to about temperature range is 4000 degrees temperature. And pressure is then tungsten electrode under the inside the bulb or whatever tube or whatever range, pressure is 0.5 kg per centimeter square. And up to temperatures are current up to 150 ampere. And where is the voltage, open circuit voltage of the two electrodes of 80 to 100 volt. So the ranges we are using here. The hydrogen atomic hydrogen arc welding, same process for giving supply. Then inside the one tungsten is a metal, it's a pure metal. Then at rake bulbs into in home appliances also bulbs are there inside the tungsten filament. When a tungsten filament immediately to heat, it reaches to high temperature. Then inside the hydrogen gas, due to this also it so hydrogen gas, then it produces the arc, then automatically so by filler rod also there, then filler rod to be heated, then to heat a base metal and then electrode, then automatically to join the dissimilar metals, welded the metals. So one more type is inert gas metal arc welding. Inert gas metal arc welding means the tungsten electrode we are taking inside here. So generally inert gases, say the argon or neon, whatever it may be, then I can use this. So most of the cases we are preferring argon metal, argon inert gas. Same process here. Then when I given to supply metal, tungsten filament is heated inside the argon gas. Then also it produces the heat. It creates a arc and to join the or to weld the metal. Advantage is generally flux is not required since inert gas envelope protects the molten metal without forming oxides and nitrates. So the weld is smooth, uniform, and ductile. So one more important advantage of this here, if you are using inert gas, some oxide formation is very less. Then automatically loss also will less compared with other type of arc methods. Applications case, welding employ light alloys, stainless steel, welding of non-ferrous metals such as copper, aluminum. So again, welding purpose, we can use this. Next, one more type is submerged arc welding. If you are seeing here, this is the submerged arc welding. So one is electrode, floor bluster here. This is the shape of like this here. Molten metal. So molten state. This is almost not in solid state, so convert into other state. Parent material. This is the parent material. If you are giving then the submerged arc welding case, then electrode and floor buster it creates, then I'm going to supply or means here, then automatically it produces the flux around here. Due to this flux, arc will produce, then automatically molten metal and parent metal, so to heat and up to then, so we what submerge to add or weld or to melt the two metals, and temperature voltages is 25 to 40, and here current ratings are 600 to 1000 ampere. For AC, DC side 600 to 1000 and AC is 2000 amperes. So here generally deep penetration with high quality weld is possible. Job with heavy thickness can be welded by using this submerged arc welding. And one more thing is submerged arc welding can be done manually or automatically. And applications is heavy steel plant fabrication work we are using submerged arc welding. And shipbuilding industry and splicing and fabricating submersibles, manufacturing vessels, tanks purpose we are using this submerged arc welding. And one more type is one more type is electron beam welding. Electron beam welding, here if you are seeing this is electron beam welding here. So where we are the electron beam welding case, we are doing HVDC supply. So this is to vacuum beam, electron beam. Generally, we have to give to the supply, this supply to the coil is heated. This is whatever the heat produced here, this heat is electromagnetic focusing lens. Then focusing lens, then heat, then what is light is focusing on here means then this whatever the beam reflect to this metal, then workpiece, automatically this workpiece is heated and to melt, or then automatically melt means then automatically to join another dissimilar metal. That is the process involved here. Supply is not directly connected to directly to heat this electron electron beam welding case. So coil is heated, it produces the heat. This light sense or heat is processed to the electromagnetic focusing lens. Lens is again reflect to the transfer to the projection place. Then atom transfer to the metal. Metal is to be heated, like indirectly to focusing on the metal. Then light focusing on the metal, then automatically heated. Advantage is here this process some high range of materials, then automatically then what is some costly type of materials to melt or melting or to joining this metals purpose wherein this electron beam welding. Disadvantage is very losses are more here, refractive materials, combination dissimilar materials, many of a type of equipment, vacuum chamber, and equipment is more we are using here. This is the more disadvantage of this electron beam welding. Another type is laser beam welding case also. Laser beam, say flash tube, where the electrical input here. So triggering device, triggering wire, then automatically like switch, it act as a fuse type. When you are giving electrical input here, so unnecessarily capacitor bank also there to they set the equivalent voltage here, and electrical input to give to supply here, and flash tube to be heated surrounding the lasting material here surrounding the coil, flash tube, then automatically here then heated, and it produces, it creates a arc. This via focusing lens, not directly to via focusing lens. Some few of material is it's not outside of this focusing lens. Only few of it is passed to the metal. Then work similar to electron beam welding. So another type. This is a laser beam. It's like beam. We all know that laser light. So laser light, laser light functioning, it's a certain particular whatever the exact point to focusing, then automatically immediately within a short span to heat, it gives the more heat. Similarly here also, workpiece to be heated and to melt the this workpiece and to join the another dissimilar metal. Here flash tube, which type of material we are using this flash tube is the thick xenon material. This is also one of a chemical compound, xenon material, flash tube material. And surrounding the coil, which whatever the means, then to focusing lens, well, and this is also cost based the compare with metal arc, carbon arc. Somewhat is cost is high here, this laser beam welding. So one more important thing, while this electrodes case, this arc welding case, what are the types of welding electrodes we are using here? So different types of electrodes here, consumable electrodes, non-consumable electrodes, Again, these consumable electrodes, we bare electrodes and coated or sugared electrodes, and again these coated electrodes can be dipped or lightly coated and heavily coated electrodes. Different types of electrodes. So consumable electrodes, non-consumable electrodes. Here in this case, for a non-consumable of electrodes are we do not consume or fuse during the welding process are called non-consumable electrodes. So consumable electrodes consume some few of metal or element. Maybe carbon, graphite, and tungsten do not consume during the welding. Consumable electrodes which are consuming during the welding process. What are the examples of non-consumable? Carbon, graphite, tungsten. And so then consumable electrodes are then what are the materials means then at some few of part of material to be consumed. So generally what are the means then again this consume bare electrodes and coated. Again consumable electrodes are bare electrodes and what is this then one more type is fluid electrodes. So bare electrodes are these are bare electrodes means consumable electrodes. We are not coated with any fluxing material. They are not coated. Bare electrodes are in the form of wire. So type bare electrodes means the form of wire. So and stuck between workpiece and electrode wire. So where we are putting this bare electrodes means stuck between workpiece with the base metal and electrode wire. So electrode is melted down into the weld with the molten metal electrode and workpiece exposed atmosphere either whatever missing the oxygen or nitrogen environment. Then from their oxides nitrates then automatically it creates a arc and arc means the arc created then automatically to heat the metal or to convert into molten state and to join or another material, another metal. Next is coated. One more type is coated electrodes. That is consumable electrodes, coated electrodes. Again, these coated electrodes, lightly coated electrodes and heavily coated electrodes. Lightly coated electrodes, the coating material is less than 1 mm. 1 mm, lightly coated electrodes. So this is also consumable electrodes, but coating the coating of material based on this, we have to divide lightly coated and heavily coated. Lightly coated less than 1 mm of coating material. So then heavily coated means then more than that. Then automatically heavy means more than 1 mm. Then I have to so coating material is more means it formation of oxides, nitrates to prevent here. Then heavily coated, lightly coated to easy way to formate the nitrates and oxides. Then automatically size will increase. Then heating temperature also is more temperature is required to melt the metal. So generally already I discussed resistance and arc welding. What is the comparison of between resistance and arc welding here? Resistance welding, arc welding case, source of supply is AC supply, source of supply either AC or DC. So generally resistance welding case is supply then either AC or DC. The head developed is mainly due to the flow of contact resistance. Heat developed is mainly due to the striking arc between electrode and electrical workpiece. And temperature attained by the workpiece is not so high here in carbon arc welding. Then temperature of arc is so high, so proper care should be taken during the arc welding case. Here external pressure is required, so no external pressure, non-pressure equipment here, non-pressure arc welding is so the arc welding, but here external pressure is required in resistance welding case. And filler material is not required to join. Suitable filler electrodes is needed for an arc welding case. It cannot be used for repair work. It can be suitable for mass production, and it is not suitable for mass production. Arc welding is not suitable for mass production, but resistance arc welding is suitable for mass production. Can't repair, but it can repair here. Power consumption in resistance welding is low. Power consumption in resistance is high. Arc welding is high. Power factor is generally carbon arc welding is power factor is low. Operating power factor is high. Here is operating power factor is high. Operating power factor is low. Operating power factor is high. And bar and roller and flat type electrodes are used. SM is not consumable. And bare and coated electrodes are used consumable and here in this case. It's about different differences between carbon arc welding and electrical arc welding. So this is about carbon arc welding and resistance arc welding and carbon arc welding. do welding methods. Next class we'll discuss the remaining topic of this welding methods. And these problems are not there in welding topic. Only the problems are with heating concept only, dielectric heating in second unit. Okay, ma, thank you. So one more important thing, I will share recorded video. And already recorded audio is already totally recorded. Then I have to later I will share.